BC Chemistry, Unit 4, Calculations in Titration, Volume to Volume Stoich. Now, in this session, before we start, you need to absolutely know that how acid and base react and know their products, or being able to predict their products, and to be able to balance a chemical equation. Now, we will revise how to calculate molar concentration and how to do stoichiometry, as these two skills some of you have learned from year 11 or earlier in the study design. Okay. Now, let's revise the mole. First, the two equations that we'll be using, one of them is how to convert between mole and mass. That is very, very basic. Okay. And another formula that we will be constantly revisiting is the calculation of concentration. So the relationship between molar concentration and the amount of particles in a particular solution. Okay. So the concentration for our molar concentration is normally shorthand to M, molar concentration, mole. Okay. So now let's start with a mole stoich. How many moles of hydrochloric acid will be made from reacting 3 moles of hydrogen with excess chlorine? So if chlorine is in excess, we don't have to consider too much of it. Then think about 1 mole of hydrogen gives 2 moles of HCl, according to the balanced chemical equation, right? So then how many, like 3 moles of hydrogen could give, it's a simple ratio question. You have done that in year 9, year 10 in your math class, okay? So stoich, mole stoich is exactly the same idea. You're using a ratio to find your unknown, okay? Related back to mass stoich, we have the same process where we went from mass of substance known till mass of substance unknown, and our bridge in between is the mole ratio from an equation. The same thing with volume to volume stoich as well. We normally know the concentration of a standard solution in titration. We normally call it that, right? We know our titer, which is our V here. We know the concentration and the titer volume of the known substance. And in order to find out the concentration of the unknown liquid, the things that we want to actually analyze, right? The bridge, again, is a balanced chemical equation. Now, there's actually a step-by-step process in this, okay? So you need to think sequentially and not let your thoughts precede one another, okay? First, write a balanced equation for the reaction. Then determine the volume and concentration of the known solution, which one do you know? The one that you know both concentration and volume, okay? Then use N equals to CV to find the mole of the particular reactant that you know. Then use the mole ratio to calculate the amounting mole of the target substance that you want to analyze, you want to find out the unknown, okay? Then use the same equation, rearrange it to revert back to find out the concentration. Okay? Remember, the ratio given by the equations are in mole, so always convert everything into mole before you use the balanced equation, use the ratio. Now let's look at a more straightforward example. So the volume, what volume of 0.5 mole of hydrochloric acid reacts completely with 25 ml of 0.1 mole of concentration of CaOH2? Now, the salt formed in this acid-base reaction is calcium chloride. Well, how nice that they actually tell you. The acid base, the salt is sodium chloride. Write and balance your reaction first, okay? Second step, we know both volume and concentration of CaOH. So that's obviously what we know. But we don't know the amount in mole of HCl. So that's the unknown. And what we need, we have the concentration in this case. What we need is the volume, okay? So we use the amount in mole of CaOH2, find out that. Use the ratio of the chemically balanced equation, 2:1 ratio, to find out the amount in mole of HCl. Then we rearrange the concentration formula to make V the subject and put N. N is what we found out, the amount in mole of HCl, okay? Divided by its concentration, which is given in this case in the question, to find out the volume that's actually needed for this neutralization reaction to go forward. Now, in year 12, welcome to the big boy table. You're most likely to see a question like this. First of all, it goes on for 2 pages. Okay, so normally what you will be given is what they're trying to do. And in this case, very, very nicely, a balanced chemical equation is given. And you can see that both the substance and sometimes the ratio, the whole equation becomes a lot more complicated compared to our prior example here, right? This is a more of like focusing on how do we calculate the particular quantity. And in year 12, in titration, you have more of a context. And more than that, the actual amount that you need to extract, like the data that they want you to use for calculation, is somehow mixed in a bunch of steps. And these steps are normally characterized as titration. A side note here, if your practical investigation is a titration, I highly recommend that you go through some of the VCAL questions and see how they write the steps so as to formulate your method part of the practical report. Okay. However, good news is, although the questions has become a lot more complicated, the steps are exactly the same. You don't believe it? Let's try. Step 1, write a balanced equation. It seems that we already have that, okay, very nicely, yeah? Then the second step is to determine the volume and concentration of known substance, then use the N equals CV to find the mole of that reactant. So which one is our known? Based on your titration technique knowledge, and based on the first paragraph here, we are using a standardized MnO4 solution to titrate the oxalic acid here, okay? So our known is definitely standard solution of KNMO4, and the amount in mole can be calculated as this. Now let's go back. We know that here, we can cross off. The next step, use the mole ratio from the equation to calculate the amount in mole of the required substance. Then rearrange the formula to calculate mole or volume or concentration. Okay, so our balanced equation is here. Okay, mole ratio 2:5. Which one is what we know? What we have just calculated for MnO4. This equation is given in an ionic fashion. By now, you should know that this is exactly the same if I write KNMO4 here. And also for C2O4, it's written in the ionic form, but it's exactly the same. It doesn't affect our calculation, even if I write H2C2O4 here, okay? So calculate the unknown amount in mole and determine the concentration as follows, okay?